This is the Earthquake Mechanics Group at the University of Michigan. Today, we're going to challenge ourselves and give a short introduction of our AGU presentations. So first, let's welcome Meichen Liu, who is going to introduce her presentation.
Hi, I'm Meichen Liu, a fourth-year PhD student in Yale School. My poster is on Tuesday about the attenuation in the mantle. We use a time domain and a frequency domain to calculate the attenuation factor along two different corridors. One is from the US array to the northwestern Pacific, and one is to the South America. We find that the attenuation factor behaves differently along two different corridors. It has a larger slope. With the distance difference along the corridors to the northwestern Pacific than to the South America, indicating that the attenuation has a larger intensity effect beneath the corridors to the northwestern Pacific.
All right, so our next presentation is given by postdoc Amir Salaree.
Hi, my name is Amir Salaree. I'm a postdoc at the Department of Earth and Environmental Sciences at the University of Michigan. And in this year's AGU, I'm going to be presenting an eLightning talk on a new metric for the performance of DART arrays and potential improvements, future improvements to DART network in Cascadia. DART are these ocean bottom pressure sensors that are typically used to monitor the propagation of tsunamis. They are often installed along or near active subduction zones. As you can see in this figure, their coverage is not ideal. This is sparse because DART are expensive and difficult to deploy and maintain. So it's ideal to pinpoint locations for potential future deployment where you could get the most coverage by the least number of stations. We've used a large number of numerical tsunami simulations from various rupture scenarios in Cascadia. And we've tried to build a metric we call D in order to just do that. If you're interested in learning about this metric and how we do this, please tune in to our eLightning talk at the AGU. Thank you.
Great. So let's go to the next presentation. It will be given by our graduate student, Prithvi Thakur.
Hi everyone, I'm Prithvi Thakur. I'm a fifth-year PhD candidate, and this AGU I'm going to talk about imminent seismic velocity changes in fault zones and its effects on fully dynamic earthquake cycle simulations. Now, predicting the onset and timing of fault failure is one of the ultimate goals of seismology, and one direction towards understanding this in relation to earthquake forecasting is looking at precursory signals preceding large earthquakes. I use numerical models with a prescribed precursory velocity drop based on a fault slip rate threshold in order to simulate this behavior. And the highlights of our study are on the bottom left figure. I compare a couple of results with different precursor onset durations. And we can see that larger precursory duration causes earthquakes to nucleate earlier. Furthermore, on the right-hand side, top and bottom figure, I'm comparing two simulations with and without precursory signals, and we infer that the earthquake nucleation size and duration are significantly reduced with the introduction of precursory signals, and such precursors of even a 0.5% velocity reduction facilitates the slow slip events to grow into large earthquakes. I invite you to attend my live talk on Thursday from 1:18 to 1:23 p.m. December 16th. Thank you.
Cool. Let's go to the next presentation, which is given by our second-year graduate student, Gable. So this will be her first time to give an oral presentation in AGU.
Hi everyone, my name is Sydney Gable and I am a second-year PhD student, and on Thursday, December 16th, I will be discussing my research on using a relative amplitudes technique to recalculate magnitudes and determine the magnitude frequency distributions for the 2011 Prague, Oklahoma sequence. We choose to recalculate these magnitudes because of disagreement between the moment and local scales for the same events. Using this method, we're able to recalculate nearly half of the events in a 2-year time period between March of 2010 and March of 2012, We then use these new estimates to determine the magnitude frequency distribution and b-values for the whole sequence and over time, using a new method from van der Elst 2021, which only requires the differences between successive magnitudes. From our analysis, we conclude that the relative method is a viable way to re-estimate earthquake magnitude, and we find that any variations in the b-value generally do not exceed a 15% margin of the b-value for the entire catalog.
Great. Okay, so our last presentation will be given by graduate student Meichen Liu.
Hello, my name is Jingci and my project is on the frequency difference back projection of earthquakes, or FDBP in short. Back projection is an earthquake rupture imaging technique. While conventional back projection stacks the phase of each frequency, FDBP back projects the phase difference of frequency pairs instead, which simulates a wave at the difference frequency. We conducted systematic uncertainty examinations and found that FDBP can potentially reduce the impacts of travel time errors and coda waves. In addition, we successfully applied FDBP to the 2015 Gorka main shock, and our results suggest that the performance of FDBP is comparable to that of conventional back projection.
So this is a summary of our AGU presentations. I hope you enjoy it and see you in AGU.